Hello, my name is Evan Collins, and I'll be walking you through how to measure VA by steam distillation. VA is expressed as acetic acid and comes from three main sources: yeast, bacteria, and post-fermentative oxidation. The typical accepted ranges for VA in wine is between 0.2 and 0.4 grams per liter. Wines containing greater than 2 grams per liter are considered spoiled or vinegar. VA is also highly regulated, with greater restrictions on wines produced in California. The principle of steam distillation involves passing a flow of steam through a sample and heating it, allowing the volatile components to be swept up with the steam into a cooling condenser, where the steam cools to a liquid distillate. The distillate is collected into a container that is titrated with a base such as sodium hydroxide. Lab personal protective equipment is required to conduct this experiment. This includes goggles, gloves, lab coat, pants, and closed-toed shoes. Broken glass is a hazard of this method, as the heating element is in contact with the glass. This could lead to spillage if the boiling chamber is broken. It is important not to turn on the heating element when the boiling chamber is empty to avoid breakage. A cash still is needed to run this method and is comprised of multiple pieces. The boiling chamber contains the heating element, which heats up the distilled water, pushing steam through the sample. The funnel above the inlet stopcock allows water to be entered into the boiling chamber or sample to be entered into the sample chamber, depending on the orientation. The top joint allows the vapor to travel from the sample chamber into the gram condenser, cooling to a liquid distillate. The evacuation stopcock allows the sample to be flushed from the sample chamber when parallel. Additional materials include 4 reagents: 0.05 molarity sodium hydroxide, distilled water, 0.3% hydrogen peroxide, and 1% phenolphthalein, as well as the cash still, 50 milliliter burette and stand, 250 milliliter Erlenmeyer flask, a small glass funnel, a waste beaker, small Erlenmeyer flask for sample, a 10 milliliter volumetric pipette, a 1 milliliter volumetric pipette, and DI water wash bottle. Before operating cash still, make sure all water lines are secure. Before operating the cash still, take note of both the stopcocks. The stopcock on the right indicates the inner and outer boil chamber. If the eye is up, this indicates the solution will enter the inner chamber, also known as the sample chamber. If the O is up, this indicates that the solution will enter the outer chamber, known as the boil chamber. The center stopcock is known as the sample chamber evacuation stopcock. When perpendicular, the stopcock is closed. When parallel to the joint, the sample will be flushed from the sample chamber into the water lines and into the sink. Making sure that the stopcock indicates the outer chamber, use the top funnel to add distilled water to the boil chamber, covering the bottom of the sample chamber by at least 2 inches. With the stopcock still indicated for the outer boil chamber, slightly turn on the water pressure and turn on the heating element. Allow the distilled water in the boil chamber to boil, releasing vapors to the top funnel. This will help remove any imperfections that are remaining in the water. To prepare your sample, measure 1 milliliter of 0.3% hydrogen peroxide. Then measure 10 milliliters of the wine you are testing and add to the same flask. Making sure that the stopcock is indicated for the inner sample chamber, add your 11 milliliters of sample into the top funnel. Rinse with DI water to ensure all the sample is in the sample chamber. Then turn your stopcock to the outer sample chamber and turn on heating element. Place a 250 milliliter Erlenmeyer flask underneath the condensing column. This will collect the distillate. Once the boil has started and vapors are being released from the top funnel, turn the stopcock perpendicular, closing the stopcock, filling the funnel with DI water to ensure an airtight seal. As the water in the boil chamber boils, it passes steam through the sample. This is carried through the top joint into the condensing column, where it is cooled to a liquid distillate. Once 100 milliliters of distillate has been collected, turn off the heating element and turn the center stopcock parallel, flushing the sample from the sample chamber. To rinse out the remaining sample, turn the right stopcock to the eye indication, allowing the water still located in the funnel to rinse the remaining sample. To prepare to titrate the distillate, fill the burette with 50 milliliters of 0.05 molarity sodium hydroxide. Before beginning your titration, be sure to add a few drops of phenolphthalein indicator to the Erlenmeyer flask containing the distillate. Record your starting volume, then begin your titration. The titration generally only uses a few milliliters of sodium hydroxide before reaching the end point of the titration. The end point should look like a faint pink color that persists for longer than 15 seconds. After the titration is complete, record the final volume of sodium hydroxide left in the burette. To calculate the volatile acidity as acetic acid in grams per liter, use the following equation. If we use the data points collected in today's example, we get an acetic acid concentration of 0.48 grams per liter. The pros of this method include the low volume of wine sample needed to test, no hazardous waste being produced, and a relatively low equipment cost for the cash still and reagents used. The cons of this method are its multiple causes of error. This includes interference from CO2 and SO2, not using distilled water in the boil chamber, letting the water in the boil chamber get too low, and sample loss due to suction into the boiling chamber.
That's all, folks.